Assalamu alaikum. In this lecture, we will study about binary numbers. And to do so, we will start our discussions with decimal number, such as 7,392 represents a quantity equal to 7,000 plus 300 plus 9 tens plus 2 units. The thousand, the hundred, etc. are powers of 10 amplified by the positions of the coefficients. As this has 1000 place, so it can be like 10 raised to power 3. This has 100 place and it can be like 10 raised to power 2. It has this place value. To be exact, this can be written as 7 into 10 raised to power 3 is 7000 plus 3 into 10 raised to power 2 plus 9 into 10 raised to power 1 plus 2 into 10 raised to power 0. Now, however, the convention is to write only the coefficients and from their position deduce the necessary power of 10, like 7, 3, 9, 2. That is becomes 7,392, and from their position deduce the necessary power of 10. In general, a number with a decimal point is represented by a series of coefficients as a sub 5, a sub 4, a sub 3, a sub 2, a sub 1, a sub 0, point, this is point, a sub minus 1, a sub minus 2, a sub minus 3. In general, I can write any one like these are the numbers, and subscript we always write the numbers, and this can be written as a sub j. Now this a sub j coefficients are one of the 10 digits. A sub j can be 0, 1, 2, 3 up to 9. So it can be a sub j can be any one of these numbers, and the subscript value this j gives the place value, and hence the power of tens by which the coefficients must be multiplied. And more precise way, I can write this one as like these a sub 5. So it's a coefficients multiplied by power of 10. So it is like 10 raised to power 5 into a sub 5. So this is the coefficient, this is the place value, plus 10 raised to power 4 with a sub 4 plus 10 3 a sub 3 plus 10 square a sub 2 plus 10 a sub 1, here also 1 plus 10 raised to power 0 with a sub naught plus, so these and a with 10 into raised to power minus 1 subscript, and plus 10 minus 2 a sub minus 2 plus 10 minus 3 into a sub minus 3. So the convention is to write only the coefficients and from their position deduce the necessary power of 10. So we ignore these numbers, these powers of 10s. Whatever you see over here, we deduce it from their positions, and these coefficients like a sub 3, a sub 2, these must be written as in this example. You can see now it has a sub 0, this one is a sub 1, this one is a sub 2 and a sub 3. Well, if you see, I haven't mentioned any tens with this power, so this is the conventional way. So we ignore the powers of tens and we write only the coefficients, and from their places we deduce their respective place. tens place. So this is actually thousand place as it is on fourth place. So this is a decimal number, and the decimal number system is said to be a base 10 or radix 10. Base 10, it can be like base 10 or radix 10 because it uses 10 digits. Because it uses these 10 digits and the coefficients are multiplied by power of 10 as you see over here. Now with this said, let's move on to binary number system. So the binary system is a different number system, and you have to remember two things about these binary number systems. First, the coefficients of binary number systems have two possible values, that is 0 and 1. And second, each coefficient a sub j is multiplied by 2 raised to power j. For example, the decimal equivalent of a binary number 11010.11 is 26.75. I will show from the multiplications of coefficients by power of 2. So let's solve this one. In this example, this 0 is a sub 0, this one is a sub 1, this is a sub 2, this one is a sub 3, and this one is a sub 4. And this decimal part, this one is a sub minus 1, this one is a sub minus 2. Well, I have to write each one of these in this form. I have to write all of these numbers in form of this one, as this j and this j is same. So over here, a sub 4 gonna multiply it by 2 raised to power 4 plus a sub 3 gonna multiply it by 2 raised to power 3 r cube plus a sub 2 gonna multiply it by 2 raised to power 2 r square plus a sub 1 into 2 raised to power 1 plus a sub 0 into 2 raised to power 0 plus a sub minus 1 into 2 raised to power minus 1 plus a sub minus 2 into 2 raised to power minus 2. Now putting the values of a sub 4, a sub 3, a sub 2, a sub 1, a sub 0, a sub minus 1, a sub minus 2. From these, and after simple calculation, we will get this result. So for a sub 4, I will have to write this one, a4 plus. For a sub 3, I have also write 1. So you can see 1 and 2, 2, 3. A sub 2, that will be equal to 0 and 2, 2, 2, a sub 1, 1 and 2, 2, 1 plus a sub naught is equal to 0 and 2, 2, 0 plus a sub minus 1 is equal to 1 and 2, 2 minus 1 plus a sub minus 2 is equal to 1 into 2 minus 2. This 1 and 2 multiplied 4 times with itself will get us 16 plus 1, 2 multiplied thrice with itself will get us 8 plus 0 and 2, this get us 4 plus 1 and 2, 2 plus 0 and 2, 1 plus 1 and 2, 1 by 2 plus 1 and 2, 1 by 4 from this one. So I will get 16 plus 8 plus 0 plus 2 plus 0 plus 1 by 2 is equal to 0.5 plus 1 into 1 by 4 will get us 0.25. So 16 plus 8 will be equal to 24 plus 0 plus 2, 26, and from this one it's equal to integral part is 26, and this will get us 0.75. So you can see this equal to this thing. With this example done, let me recall what I did earlier in decimal number system. I write a raised to power 5 into a sub 5 plus a raised to power 4 into a sub 4 plus 10 cube a sub into a sub 3 plus 10 square into a sub 2 plus 10 into a sub 1 plus 10 raised to power 0 into a sub 0 plus 10 raised to power minus 1 a sub minus 1 plus 10 raised to power minus 2 into a sub minus 2. This is for decimal number systems. I have wrote it earlier in this lecture. Well, I also write for binary number system a sub 4 into 2 raised to power 4 plus a sub 3 into 2 raised to power 3 r cube plus a sub 2 into 2 raised to power 2 plus a sub 1 into 2 raised to power 1 plus a naught into 2 raised to power 0 plus a sub minus 1 into 2 raised to power minus 1 plus a sub minus 2 into 2 raised to power minus 2. Let me name this expression as 1 for decimal number system and this one, and this expression is 2. This is expression 1 for decimal number system and this expression 2 for binary number system. I can clearly see in binary number system a number expressed has coefficients multiplied by power up to. You can easily see that coefficients multiplied by power up to. While in decimal number system a number expressed has coefficients multiplied by power up 10. You see this power up 10. So in general, a number expressed in base R system has coefficients multiplied by R. So base R system, R can be any number. It can be base 5, it can be 6 or any number. So simply we can write it as a sub n into r raised to power n plus a sub n minus 1 into r raised to power n minus 1 plus up to we keep on decreasing. You see, if this is 5, this can be 4 as over here. It's keep on decreasing. The base or the subscript value is keep on decreasing as you go from left to right. So the same happens over here as well. Well, this base is same to this one and we keep on decreasing to this one as you go across this number. So R can take any value. Well, again recalling from decimal number system, the coefficient a sub j range in value from 0 to 9, that is 0 1 2 3 4 5 6 7 8 9. This 9 can be write as, let me write it as in decimal. 9 can also be written as 10 minus 1. So it ranges from 0 to 10 minus 1 or 9. It can also be written 10 to 9 and 0 to 10 minus 1. You know, this is decimal number system. Well, the coefficients in binary number system, you know that these are 0 and 1. Again, let me write it here. Binary number system. The coefficients of binary number systems have two possible values, that is 0 and 1. You know, and this can be also written as a sub j. These are coefficients 0 and 1. It can take either this value or this one. This one can also be written as, this one can be written as 2 minus 1. Now by inflection we come across the things that coefficient ranges in value from 0 to r minus 1. As so in base in this system, the coefficient a sub j range in value from 0 to r minus 1. Coefficient range of coefficients a sub j will be from 0 to r minus 1. It means that if we have base 7, then the coefficients will be from 0 to 6. Okay, for base 7 number system and as the coefficients will be from 0 to 7 minus 1. It will be from 0 to 6. Okay. We move further to distinguish between numbers of different bases. We encloses the coefficients in parentheses and write a subscript equal to the base used, except sometimes for decimal numbers where the contents make it obvious that it is a decimal. So there is no need to mention its base. Let me write an example of base 5 number. Base 5 number system. So by observation I can clearly write it as 4. This is coefficient and base is 5 raised to power 3 plus this is coefficient 0 into 5 raised to power 2 plus 2 into 5 1 plus 1 into 5 0 plus 2 into 5 raised to power minus 1, and after simplification I will get 511.4 to base 10. Well, it can be also written 511 with nothing over here. Note that coefficients value per base 5 can only be 0, 1, 2, 3 and 4. As I told you, it can ranges from 0 to r minus 1, so 5 minus 1, that gives me 0 to 4. This can be the coefficients in base 5. With this said, it is customary to borrow the needed r digits per the coefficients from the decimal number when the base of the number is less than 10. Well, the letters of the alphabets are used to supplement the 10 decimal digits when the base of the number is greater than 5. For example, the hexadecimal, where the base is 16 number system, the first 10 digits are borrowed from the decimal system, and a letter that is from alphabets A, B, C, D, E and F are used per digits 10, 11, 12, 13, 14 and 15 respectively. Let me write it. This one is hexadecimal numbers can be write as this way. So you can see that the letters used A, B, C, D and F are used per digits 10, B per 11, C per 12, D for 13, E for 14 and F. As it is a base 16 number system, hexadecimal or radix 16, so it will have a coefficients 16 minus 1, that is 15, from 0 to 15. You can see it. An example of hexadecimal number will be B65F to base 16, and this will be equal to B into base 16, 3 plus 6 into 16, 2 plus 5 into 16, 1 plus F into 16 raised to power 0. This B is equal to 11 into 16 cube plus 6 into 16 square plus 5 into 16. This F is equal to 15, and anything having power 0 is equal to 1, and eventually I will get 46,687 and decimal number system. Well, we always write it without its base, so 46687 is the answer. If you like my lecture, do subscribe my channel, and next lecture we will study arithmetic operations with base r and binary numbers and decimal systems, inshallah. Thank you.